Hi, welcome to the Physionic Podcast, or welcome back to the Physionic Podcast. Thanks for stopping by. My name is Nicholas Verhoeven. I'm a PhD student in molecular medicine, and today we're going to be going over a study that is incredibly intriguing to me. The study is called 2 Weeks of Early Time-Restricted Feeding, ETRF, Improves Skeletal Muscle Insulin and Anabolic Sensitivity in Healthy Men. Now, what does that all mean? Well, it means that we're going to be looking at Chrono nutrition, which is something that I've been wanting to delve into in further detail. And there's some really cool aspects of this particular study. I'm not going to be covering all the information in this study because it is rather expansive. However, I'm going to be focusing our information on intermittent fasting, and we're going to be comparing that to a non-intermittent fasting group. But here's the cool part: the calories, the amount of food consumed, is equal between both groups. So we're actually going to be able to tease out what effect intermittent fasting, or the changing in the time period of consumption, has on health. And what health markers? Well, those health markers are insulin and glucose uptake, or blood sugar uptake. So improved blood glucose levels, blood sugar levels, and improved insulin levels. So essentially talking about insulin sensitivity. So really cool study. Before I get into it, I'd like to announce that I hit 1,000 subscribers on Instagram, so it is certainly a small number by comparison to fitness influencers and all the other people on Instagram, but I wanted to extend my greatest thank you and gratitude to those people who did decide to join me on Instagram. You can check out a greater breakdown of this study on Instagram, as well as some additional information on all the other studies that I've covered over the podcast history, or, well, over the last recent podcast history. And with that, let's go ahead and jump into this study. So let's go into a bit of the background on Chrono nutrition and what information is already kind of out there. So most studies focus on diet composition and energy intake. But diet composition being the macronutrients and micronutrients, and then of course just the overall intake of energy. And that's pretty much been the predominant way of looking at nutrition, just not really focusing on the timing of nutrition or the fasting element, for example. But more research actually needs to be done when it comes to chrononutrition. Chrononutrition is literally just looking at the timing of nutrition throughout a day and how it impacts health markers independent of things like, let's say, calories, which is what we're going to go into. So the times of day that a person consumes food, like intermittent fasting, which a lot of people are doing right now, myself included. I intermittent fast from time to time. So apparently studies looking at rodents have found that there are favorable metabolic effects of time-restricted eating, intermittent fasting. And anytime that I reference time-restricted eating, I'm literally talking about intermittent fasting. And I'll go ahead and tell you one piece of information. This study is highly applicable because it is applicable in the way that it is a 16-8 intermittent fasting. So it is one of the most common types of intermittent fasting. So I'll be really excited to kind of divulge that information. Or you can just skip to the end and get the takeaways and conclusions if you don't care about the data breakdown and the physiology explanation. So, but anyway, time-restricted eating or intermittent fasting does lead to favorable metabolic effects. Some of those would be like reduced triglycerides or blood fats, improved glucose tolerance. That's another way of sort of saying insulin sensitivity, improved insulin sensitivity, and weight gain from hyperpalatable food, so mitigating some of that weight gain. So studies looking at overweight individuals have actually shown that simply telling people to eat all of their daily food in a 10 to 12 hour window, which is a pretty sizable window. I mean, you're talking about literally half the day. So you're only really cutting out a few hours of wakefulness there. Still, even with that pretty sizable window to eat, that still led to weight loss and better sleep satisfaction as well as improved glucose tolerance. So again, kind of going back to the insulin sensitivity, potentially improved insulin sensitivity, which is what we're going to go into. Short term, however, 24-hour intermittent fasting does show increases in fat oxidation rate. That isn't surprising. What does that mean? Well, fat oxidation is just fat use. You're using fat molecules to sustain the body, to sustain the metabolism, to generate energy for the body's cells. And after 24 hours, of course, if you're not eating anything, then of course that's going to increase fat oxidation. That is not news in any regard. This is also applied in improving metabolic syndrome. Metabolic syndrome being a series of different kind of sub-diseases or disease states like diabetes, obesity, cardiovascular health, heart health, cholesterol, things like that. And so they've looked at, of course, how fasting can affect those, and it certainly helps, as well as just overall time-restricted eating. So, however, no studies have looked at skeletal muscle anabolic sensitivity. And while this study is pretty expansive, like I mentioned, there's actually they go into more than just insulin sensitivity. They also go into amino acid uptake, which could potentially be an implication in terms of muscle growth and things like that. But ultimately, we will not be covering that in this podcast. I may cover that in future podcasts. And if you'd like to hear more on that, the effect that it has on anabolic sensitivity, the ability to generate protein, anabolism, then let me know. If I get enough feedback on that, then I will cover that particular topic as well related to this study. So the reason why they looked at that is because they think that could be an underlying mechanism for these improvements in weight and glucose tolerance, that you're getting improved sensitivity of the musculature, not just in anabolism, but also just in the clearance of glucose, again, through that insulin sensitivity. And they've shown that in animal models, but now we're going to be looking at humans. So other studies have noted that there are favorable metabolic responses to meals consumed earlier in the day as opposed to later in the day, so eating in the morning and kind of the afternoon is better in terms of these metabolic outcomes, reduced triglycerides, improved glucose tolerance, etc., if a person consumes earlier in the day as opposed to consuming more later on in the day. So, with all of that introduction out of the way, what is the purpose of this study? Well, the study aims to compare the effects of 2 weeks of early intermittent fasting, meaning that they're intermittent fasting, they are eating food early on in the day and then fasting for the rest of the day. And they're comparing that versus an energy or calorie intake matched without intermittent fasting. So they're taking two groups, and I'll go into the study design in more detail, but they're taking two groups of people. One group is being told, hey, you're intermittent fasting you're fasting for 16 hours and you are eating for 8 hours. And they're taking another group and they're saying, hey, you're going to be eating the exact same amount as the other group, but you can eat your food throughout the entire day. So they're going to be comparing those two. And then they're going to measure whole body and muscle-specific insulin and anabolic sensitivity in healthy individuals. We're not going to be focused on the anabolic sensitivity, but I am going to be focused on insulin and glucose uptake. And I'll be going into a bit of the physiology as well near the end. So a bit on the study design before we go into a little bit of breaking down the data. And if you're listening to this, as usual, don't worry, I'm going to be explaining things as I go along, so it's not required that you watch the podcast, although there is a video version of this podcast that will be uploaded. So the two groups are made up of healthy, young individuals. I think the top end of the age range was 35. And they were put into two groups, like I mentioned briefly. And they consumed their food for the day in a time-restricted manner, so the intermittent fasting group, or the other group consumed an equal amount of food, but not in a time-restricted manner. And from what I remember, they had... both groups, I've got that in my notes, both groups actually were in a calorie deficit. So, and we'll see, I might as well... I'll tell you in just a second, but we'll see what effect that has. Does the intermittent fasting alone, even though the calories are matched, does the intermittent fasting lead to greater fat loss or greater weight loss or lean mass loss or whatever it might be? We'll cover that as well. So all the participants had their metabolism tested to get a more accurate reading on what their intake should be, their caloric intake. And so they had a baseline period of about a week where they kind of tweaked it for everyone, trying to figure out how much people eat, how much they need to eat so that they don't gain weight or maintain their weight because they want to be losing weight, et cetera, et cetera. And they do that through a process called indirect calorimetry. I'm not going to go into it this time, but ultimately it's a way to measure gas exchange, so oxygen, CO2, to be able to determine via kind of a proxy measure of caloric use or energy use in the body. That's as far as I'm going to go into that. If you're interested in learning more on that, you can contact me and I will let me know, and I'll make more content on it, although I do have content on it already. So the intermittent fasting group was allowed to eat from 8 a.m. until 4 p.m. So that 8-hour window, which is absolutely brilliant. I love the fact that they used an 8-hour window because it's pretty flexible. I mean, that's a pretty big window. And it's a common window. The 16-8 method of IF, intermittent fasting, is incredibly popular. So we will see what happens. Like I mentioned, both groups were in a caloric deficit, and that was actually based off of the intermittent fasting group's results. So the IF group did their part of the experiment or the study for 2 weeks, and then I think it was like 8 months or 9 months or 7 months, something like that. The other group did their experiment. They did it that way because they wanted to figure out how much of a deficit the intermittent fasting group would end up being, because they can back calculate based off of the amount of weight and the metabolism that they're measured, things like that. So that allows them then to have a little bit more control over the other group, the control group. Okay, so it was two separate times. So during testing, participants were given an equal carbohydrate and protein drink. So when they're measuring the blood glucose tolerance, the ability for the cells to take up glucose out of the bloodstream and to regulate blood sugar levels, that's blood glucose, they give them a equal carbohydrate and protein drink. And the protein drink is more related to the anabolic signaling. So again, I'm not going to be covering that in this podcast, but the carbohydrate drink is the one that we're most interested in, and the ability for it to be cleared out of the system. And I've already mentioned this, but, well, actually, no, I did mention this part. I absolutely loved this aspect of this study. Another thing that I really, really loved, other than the calorie control, the equating the calories between the two groups, what they did, and what a huge criticism that I had of a previous study on, I believe it was OMAD. I believe it was OMAD. Maybe it was something else, but that you can't have an intermittent fasting group that fasts for a longer period of time and then have them tested in their blood sugar levels and stuff like that. If you're not going to do the exact same thing with the control group, because when it comes to the actual testing procedure, the actual measuring of the blood sugar and whatnot in the laboratory, you need to make sure that both groups have been fasting the exact same amount of time, because you always have to fast to get accurate results for a blood sugar test, for example. So in this situation, what they did, and I absolutely love this, was that they consumed an equal meal. So the composition of the meal was the exact same the night before the actual testing. And that was also true for the intermittent fasting group. So for that group, for that one night, they did not follow their intermittent fasting. But for the previous 2 weeks before that, they did follow, the 8 a.m. to 4 p.m. window. That is fantastic, because then that allows us to be able to say, okay, well, it's not because of measurement error. It's not because one group was fasting from 4 p.m. and the other group consumed their last meal at 9 p.m. And sure, they may be fasted when they get into the laboratory, but the other group has been fasting for an additional 5 hours. So, and then that would, of course, that could potentially, probably highly likely, that it reflects in the blood sugar levels when they test it. So incredibly important. Love the fact that they did it. Okay. So now I'm going to touch on a little bit of the body composition. So what happened in terms of body weight, fat mass, lean mass, things like that. So again, this study was only 2 weeks for each condition, intermittent fasting and the control condition, so the normal eating condition. And there are no differences. So both groups, I believe, from what I remember, I don't have this written down, but both groups ended up losing weight. However, they did not have a significant difference in the amount of weight loss. So when you equate the calories, you're going to have the same amount of weight loss, regardless of if you're intermittent fasting or not. So that's not exactly anything groundbreaking. That's actually been true of so many other studies that I've looked at as well. Okay, so now figure 3 is where I'm starting to get things started. Okay, so figure 3, what they're looking at here, and I'm not going to be, again, if you're listening to this, don't worry, I'm going to be explaining things. So what they did here was they wanted to determine the blood sugar levels, just kind of general blood sugar levels, to see if they're elevated or if they're low or if they're kind of in the middle, if they're, throughout the day. So they did a series of tests over a 24-hour period, and that's they usually do a glucose monitor that they carry around with them, and it's constantly measuring throughout that 24-hour period. So they did that before the study started to be able to compare the two groups, just to see if there are any significant differences. And then they did that after the 2 weeks, after they went through their study protocol. Half of the people went through the intermittent fasting and half the people went through the control group or normal eating. So essentially they just consume the same amount, same as always. And what you see, I'll describe this, what you see before the study, there aren't very many dramatic differences between the two groups. Now, after the 2 weeks of the intermittent fasting, in the morning, so talking from midnight until 8 a.m., before they were consuming food, the intermittent fasting group had lower levels of blood sugar compared to the normal eating condition. However, and this was actually also true in the evening from 8 p.m. or 6 p.m., something around that time frame, all the way until into the morning, their blood sugar levels continued to decrease. And that was, again, different from the normal eating condition. Now, that would then imply, you would think then, that potentially the intermittent fasting group has overall lower blood sugar levels. But that is actually not the case. So the reason for that, and I'll show this data if you're watching, so there were no differences actually in the average blood sugar level. Now the reason for that is likely and almost definitely because in the intermittent fasting period, because they're consuming an equal amount of food, but they're consuming it all within that 8-hour window, that 8 a.m. to 4 p.m., that leads to a significant rise in their blood sugar levels that is even higher than the control group, because the control group is kind of grazing throughout the entire day. So that ultimately leads to, even though there's an advantage, quote unquote advantage, in terms of lower blood sugar levels in the morning as well as late at night, that kind of gets ameliorated, gets reduced. That effect gets reduced when you look at the total amount, or the kind of the average amount, because you have this higher level in the afternoon when they're consuming, or kind of, I guess, 8 a.m. to 4 p.m. So also including part of the morning. So hopefully I'm communicating that correctly, or well enough so you're understanding what I'm saying. So over a 24-hour period, you have more fluctuations with the intermittent fasting group because they are massing all of their food within a particular window, and the other group has more consistent blood sugar levels, although they tend to be higher compared to the intermittent fasting group. However, in total, or the average compared between the two, taking the morning, afternoon, and nighttime all together, there's no difference. Okay, so that's interesting. However, that is not the most interesting part of this study. We're about to get into the most interesting parts. So for the most interesting parts, they did a sub-analysis of the graphs, which I'm not going to throw up on the screen, but they did a sub-analysis where they wanted to figure out, how much of a difference there was, trying to tease out the differences in glucose, again, that's blood sugar, at varying time points before and after the intermittent fasting eating window. And there's a significant difference at night. That was the one where they had a statistically significant difference, implying lower glucose, blood sugar, in the intermittent fasting group in the evening. So it's if you look at just a region, a particular amount of time within a 24-hour period of time, let's say 6 hours, there may be some slight differences, some advantages for the intermittent fasting group. Now, the next thing they wanted to look at was then the whole body blood glucose clearance test. That's where they give these people a set amount of carbohydrates to consume, usually drink, and then they test over a period of time. I think it's 180 minutes that they ended up doing in this scenario. And they want to see how much of the blood sugar levels get decreased. So there's going to be a rise, right? Because you're consuming carbohydrates. There's going to be a rise in the blood sugar levels as it goes from the intestines into the bloodstream. And then how much of that over X amount of time, again, 180 minutes, let's say, so 2 to 3 hours, how much of that then gets cleared into the cells, that gets taken out of the bloodstream, and the blood sugar levels then go back down to their normal levels. And again, comparing between these two groups. And what they find is really interesting, because the intermittent fasting group experienced a decrease in blood glucose total amount over the 180 minutes. So yes, it was 180 minutes of measurement compared to their previous test. So they're really comparing the difference of before the study began and then after the study began. And the intermittent fasting group actually had higher blood sugar levels before they started intermittent fasting. So it has nothing to do with intermittent fasting. They just had higher levels. That just randomly happened. That was just the case. But once they implemented intermittent fasting, they saw the greatest reduction in blood sugar levels. However, the normal consuming group did not experience that benefit. As a matter of fact, they may have had a slight increase, but they definitely did not see a decrease in blood sugar levels. So what does that imply? That implies that the intermittent fasting group can clear glucose, blood glucose, better than the normal consumption group. And I'm not going to show the data on this, but the same was actually true for the overall insulin levels as well, with a decrease only in the intermittent fasting group. So both of those pieces of data combined, better clearance plus lower insulin, would imply then that you have better insulin sensitivity, which is really, really cool, because again, these are equated conditions. The only difference is the fact that one group is intermittent fasting and the other group is consuming all their meals. Brilliant. So they took it one step further, and here's where things get even more interesting. So the next part is they're looking at, so the previous data was looking at whole body, right? Whole body clearance. Now they were looking at more of skeletal muscle clearance. So skeletal muscle obviously is a section of our body that sucks up a lot of blood glucose. So they wanted to know, okay, do we see changes in the uptake of glucose? Higher uptake would be better. That would be implying that you have better glucose clearance. So meaning your high blood sugar would then reduce because it's being taken out of the bloodstream and put into the skeletal muscles. And in skeletal muscle, the glucose uptake measurement showed an improvement again in the intermittent fasting group, but not the control group, which corroborates the whole body clearance. It's the exact same test, but one is whole body and one is skeletal muscle. And then they took it a little step further, and they want to find out, okay, well, where's this glucose going? Once it's in the cells, once it's in the muscle cells, what's happening to it? Is it being shunted and turned into glycogen, where it's stored, or is it being oxidized? Remember, the word oxidize is what I used for the fat oxidation earlier in the introduction. That means just used up for energy. Okay? So, and what I'm not going to show you the data, but I am going to explain some of the physiology here. So looking at those measures, they find that the glycogen levels remain the same in both groups. So there's no difference, I guess I should say, between the two groups. The intermittent fasting didn't lead to more storage of glycogen, and the control group didn't lead to more storage of glycogen. However, they did see an increase in the amount of a particular, I think it was the amount or the activity. I can't quite remember, but it was an increase in a particular enzyme called pyruvate dehydrogenase complex. And what that is, let me back up real quick. It's activity measured at as the amount of that particular enzyme. Okay, so kind of both. So blood sugar, it gets taken out of the bloodstream, enters the muscle cell. Once it's immediately in the muscle cell, it begins either being metabolized or it gets turned into glycogen, stored form of glucose. But as I said, there were no differences in glycogen. So it eventually becomes metabolized and it gets turned into a molecule known as pyruvate. Pyruvate will then be found in the mitochondria of the cells. And here, the first enzyme that plays with pyruvate, that does something, reacts with pyruvate, is this pyruvate dehydrogenase complex. And that will turn it into acetyl-CoA, another molecule. And that acetyl-CoA can then goes through a bunch of different transformations, but eventually gets turned into cellular energy. So what does this mean? It's kind of a proxy to say that because we've got increases in PDC, this pyruvate dehydrogenase complex, that would then strongly imply that the glucose is not being shuttled into glycogen, but actually being shuttled into the mitochondria, and in the mitochondria, then it gets turned into acetyl-CoA to be used for energy. So that would then mean that the intermittent fasting group is then oxidizing or using more glucose. And they did not find that to be the case in fasting conditions. So that benefit is only true when you consume glucose. When you're consuming carbohydrates, the fasting condition has a better time, an easier time to take that glucose and put it into the muscle cells in this example, although other cells also oxidize glucose, and don't just store it, but actually oxidize it and immediately use it for energy. So it would imply, again, better glucose clearance. So more on a molecular level in that regard. So it's essentially saying, let's just jump straight into the takeaways. The takeaway here is that this study shows that although overall glucose levels may not differ between an intermittent fasting and traditional energy deficit, there is a reduction in insulin as well as an increase in glucose disposal, so clearance, thereby implying greater insulin sensitivity. Again, noticed in muscle specifically. So not just whole body, but also in muscle. This shows, as a one-sentence thing, this shows that intermittent fasting improves insulin sensitivity independent of calories. Super, super cool. So this is a small look into Chrono nutrition and looking at how intermittent fasting has benefits that are independent of caloric consumption or caloric reduction, weight loss, et cetera, which is one of my biggest qualms. I've talked about that many times before, or maybe I've just been talking to myself. I don't know, but I have thought about that before. That is it the calorie deficit that's leading to these benefits, or is it the actual intermittent fasting or the fasting in general that is causing these benefits? And this study is finally starting to tease out the differences there and showing that intermittent fasting specifically has this benefit. Okay, folks, hopefully you found this informative. I found it wildly cool. And let me know if you'd like me to cover more on this particular topic. Certainly I'll be covering more on Chrono nutrition, but on this study specifically. And with that, I hope to have the absolute pleasure of speaking with you in the next one. Have a good one, guys. See ya.